So we should be recording, and I'll pull this thing up, and now I should be able to write on my iPad here, and then it'll get put up on Blackboard. Okay? Now, maybe you want to keep taking notes right now because I never know. All right? So we're doing problem 12. Is that right? 11. Okay. Problem 11. Okay, if a particle has an initial velocity of 12 to the right when s equals 0, determine its position when t equals 10 if acceleration is 2 to the left. Okay, so we're going to choose an origin. Where do you want to choose an origin? At at s equals 0? Okay, so we'll put a point here and we'll say, okay, that's s equals 0. That's your origin, right? And then particle moves, let's see, particle has initial velocity, so v0 equals 12. v0 equals 12. And he's to the right, so we'll give it positive. Let's see, determine the position when t equals 10 if a is 2 to the left. Okay, so what is a? Positive or negative? Negative. Okay, so the acceleration is a -2. Okay, so we want to know position, given position, let's see, we're given velocity, we're given time, we're given a velocity. What equation did I use? Very good. You're not going to remember this because you can bring in one page of sheet, right? And I know bring in your laptop, you're going to have a PDF file. Don't do that if I catch you doing that. Bring in one sheet, right? So you won't have to memorize it, okay? But anyway, we're going to use the x equals x0 plus, right? So let's put that one down. So s equals s0 plus v0t plus 1/2 a t squared, right? So let's plug in. So s, which is what I want, equals s0. What's s0? Why? Because you chose the origin there, right? So that's 0. What's the initial velocity? 12 or minus? Y plus? Yeah, because that's what we chose to be the positive direction. So we'll put in plus 12. The time they gave me was 10. Is that right? Yeah, okay. Times 10. Let's see. Plus 1/2 a. What is a? -2. So I'll say minus 1/2 times 2 times 10 squared. Okay? So, got your calculator? Bing, bang, boom. Off you go. So it's 100. Let's see, -100. 120 minus 100. Okay, so S is 120 minus 120. Does that answer your question? Okay. Can you give me a hint as to what was causing the problem? The directions as to what was causing the problem? The directions. The directions and the equation that you didn't know when it's negative where to plug it. Is that the idea? Sure. Let me address his problem. See this? What I write the equation down, put all x equals 0 plus v0t plus 1/2 at squared. I just copy them down. Then when I number, so I pull it 0, the negative number, I get it, right? So I do this. I'd say, all right, let's take this equation right here, right? This one here. Okay, and I'll show you what I mean. I write it down like it comes out of the book with all pluses, and then I will come in and I'd say S equals, okay, and then 0, and then if this 12 to the left, if it was to the left, I would say plus, because that's what the equation is, and then I'd do the parentheses, minus 11, or 12, or whatever it is. Get the idea? So when you get confused with the pluses and minuses, do that. You're not confused, you're just fine, you're good, right? But if you get confused about it, just do that. keep everything in the equation weight straight off, and then keep everything in the equation as weight straight off, and then put parentheses, and then put your negative in there. Okay. Okay. And that might help you. Okay. Okay. You wanted me to do the next one. All right. Okay. Next one is number 12. Determine the time required for a car to travel 1 kilometer. Determine the time required. Let's see. Time required. Travel 1 kilometer down road. Car starts from rest, reaches a maximum speed at some intermediate point, and then stops at the end of the road. The car can accelerate at 1.5 and accelerate at 2. Okay. So what's going to happen is you're sitting still. You hit the gas. He's going to take off. He's going to hit a maximum speed or something. Is that right? Reaches a maximum speed, and then he stops at the road. Okay, so he's going to do something like this. So it's acceleration to start off. This will be acceleration through time. So he's going to start off with a maximum acceleration, and at some point he's going to slam the brakes. Right? Is it going to look like that? Everybody agree? Okay. This is not a constant acceleration across that, right? It's constant from this point here over to this point here. I'm not sure you can, right? It's constant from here to there, and then it's constant here to here. So how do you do problems like that? I've done them before. You break them up. So what you do is you say, okay, I'll use the equations for the areas where it's constant. Okay? And so here's what we'll say, okay, let's define this point 1. This guy right here is point 1. And we'll say this point right here is point 2. Is that okay? Right. Now let's write some equations. I'm interested in position. Right? So let me write the position. So x at point 1 equals what? Okay, this is, I'm asking you to memorize that equation. It's equal to what? At this point, do you know that's how far you? That would be over here at 2. Right? So x at 1, about the equation. X equals x0. 0 good. What's x0? 0. Okay, x1 equals 0 plus the initial velocity. Yep, 0, right? So I'm just plugging into the equation. Plus 0 times time plus 1/2 plus 0 times time plus what's the acceleration? 1.5, and it's positive, right? Times time squared. There we go. Maybe I can solve this. How many variables? 2 variables. How many equations? Okay, so I don't panic. So 2 variables. How many equations? Right? Okay. Let's see. Hold me the x at 2. That's what you all say. 1.5 kilometers, right? Okay. Okay. Whatever it is. Okay. So let's use that information. They told it to me, right? So x2 is how much? 1 kilometer. Okay. So x2 would be 1 kilometer, and that we're going to put it in meters, right? You don't want to worry. Put them in meters, seconds, newtons, kilograms, and then don't worry about units. Okay. So 1,000 meters equals. Okay. So where did he start? At x1. Okay. So he starts at x1. What's the initial velocity? Okay. So he starts at x1. v1. Okay. Good. What's his initial velocity? So we say okay plus v1 times time. Is it t minus something? T minus. Okay. So what should I put here? I put t1. Okay. So t1. T minus t1. Yeah, I should put a 1 on this guy. Right? Maybe I should put t1 here. T2 minus t1. Maybe I should make a 2 here. T2. What's the acceleration? Is that clear? Negative. It's deceleration. What's the acceleration now? It's always to the left, right? Negative. He's decelerating. Always to the right. What do they mean by decelerating? It's always to the left, right? It's opposite your motion. Always to the right. When you decelerate, whichever way you're headed, you're slowing down. That's what deceleration means. They often use deceleration both. Okay? So it'd be like saying we're all human. Some of us are men. Right? So that's the difference. It's all acceleration. Some accelerations are decelerations because they're slowing you down. Okay? So you have to cover that. Okay. So that would be negative, right? Minus 1/2. Okay. And what's the deceleration? Negative, right? Minus 1/2. 2. And what's the deceleration? Yeah, you're right. 2 times T1, T2 minus T1 squared. Times T1, T2 minus T1. Oh. Squared. Yeah, right. There's that back. Okay, good. Yeah, right. All right. How many unknowns? X1, T1, T2, V1. Man, it's getting worse. V1. Okay. Is that what you said? V1? All right, so let's do a V1. V1 equals what? All right, so let's do a V1. Initial, is that 0? What? Plus the acceleration is 1.5. 0 times T1. The acceleration is 1.5. Okay. Nothing. No. Times X1 T1. Nothing. V1 T2. Still have 4 unknowns. And I have X1 T1. What am I missing? V1 T2. And I have 3 equations. Still missing. What am I missing? What is the velocity? 0. Ha! Here we go. So you see what I'm trying to do? If you don't know 0, aha! Often we go. So you can see what somebody did to do. If you don't know what you're doing, never works. That's the case. Okay. Somebody gives you a problem, right? They come into the office. Oh, I've never worked that problem before. Okay. So instead of panicking, I just start writing the equations. How many unknowns? And I'm counting how many unknowns. I'm kind of doing this. I want to look intelligent. How many unknowns? Then if they're not matched, I'll turn it back to the suit and say, well, they don't match something else. What's given, right? And then they go, oh no, well, how do you know there's something given? Because it got to match, right? Now, if you were working for some company and you called me to consult for you, I don't know if you have a well-defined problem. Your problem may not be solvable, right? So we'll have to get into it. But these problems, they're solvable. I have too many unknowns. There is something that we overlooked. And what was it? Oh, it has to stop at the end. Okay, got it. V2 has to be 0. Okay, so I'm going to write that one. V2, 0 equals. What's the initial velocity? V1. V2, 0 equals. He's decelerating. So he's going to be a negative 2. What's the time? T2 minus T1. What's the time? Now how many unknowns do we have? 4 equations. 4. Could it be solved now? Yes. Do you want to use mathematics? Okay. Could it be solved now? Okay. I've got mathematics up here somewhere. There we go. Okay. I've got mathematics up here somewhere. And let me enlarge it so you can see it. Okay. One of the things I like to with because mathematics remembers everything from the time it started, okay, until you quit, right? So, if you're doing your homework and all of a sudden you get garbage coming out, you go, what? Do a quit and try it, okay? So anyway, we quit. Now what do we do?
Type in the equations. Okay, so I'm going to say equation, EQN. You can name it anything you want, right? I'm a creature of habit. I like to do things the same way each time. Okay, here we go. X1. Yes. No. If you want to name it,
So, for example, whenever I say EQN is the name of all of these equations, I use one equal sign. When I say this is equal to this, please solve it, I need two. So I would have done it backwards, right? Because you always write equations. But anyway, so one says, I want to just give it a name so I can refer to it. Okay?
So if you want to name it, you use one. If you want it equal, you use two. So X1 equals 0.5 times, and I just do a little space, 1.5 space T1 squared. Is that good? And I didn't put the X's in there. It comes in. I put a space, and it kind of fills it in. Yeah. I think it is. Okay, so you all got to let me know that I screwed up or not. But I believe the iPad is catching my voice. Okay, and the screen, the whole screen is recorded. That's what I think. Okay. But you might want to take notes just in case. Okay. All right. And we have a YouTube channel. So as soon as they teach me about that, oh my God, you know. Anyway, so okay, there's the first equation, and then I like to hold on to them kind of separate. 1,000 equals x1 plus v1 parentheses. So you don't need the times, right? If it's obvious that it's going to be multiplied, you don't need to put them in it. If you're in doubt, throw them in. Put in a capital E with a little star, right? Whatever. But it'll take it this way. V1 times parentheses T2 minus T1 close minus 0.5 space 2 parentheses T2 minus 1 close parentheses squared. So far, okay? Oh, you're right. Thank you. That would have given me crazy answers. You know, some time ago, I mean, I really was up on technology, and when we were using technology to teach with, we found that it was a lot easier if you're going to do your homework and things of that sort. You know, on a test, you got to do it alone. But if you were going to do homework, it was always beneficial to have people, right? But one person would do the type. The second person would read catch them like that. Okay, and it's very effective at increasing your efficiency. Okay, but you know, don't always have the same person type, right? So Monday you type, Tuesday the other person types, so that you get used to it. But you've got that other set of eyes to say, no, you made a mistake here, right? Because it's so easy to do. Okay, let's see. And then the next equation, whoops, what did I do? Okay, the next equation is V1 equals 1/5 times T1. And then the final one, 0 equals V1 minus 2 parentheses T2 minus T1. Close parentheses. Close wiggle bracket. Wiggle bracket because it's a set of stuff. Okay? And then I hit enter. And it teaches to me what the equations are. And so I like to kind of look at this and go, yeah, that's it. Right? And then what do I do? Solve them. Okay, so I say capital SOLVE, square bracket. And then I say, here are the equations, EQN. Remember, there's one equal sign on the EQN. That's why it's named EQN. to make it execute on, if you don't have a numeric keypad, still have a keypad, right? So I hit this one over here on the keypad. If you don't have a keypad, you hit down shift, any shift, hit the enter, if that's all you have. Shift, hit enter. Okay, and then it will. Okay, if you're going to use Mathematica on the exam, then you should be bringing your laptops to class and practice, because what'll happen is you'll forget a comma, you forget something under stress of the exam, and then you'll go nuts. All right, so you want to experience and get good at it. So if you're going to use it, bring the laptop. Okay. So you say, I want to solve those. Then you have to tell it what you're going to solve for. I have 4 equations, so I have to give you 4 things to solve for. What are they? X1, T1, T2, V1.
Is it X2? T1?
And there you go.
T2? V1. And there you go.
Okay. How many? All right. Yeah, there's 2. See here, between here and here, and between here and here. So which one do you take? Yeah, second one with positive times. Okay. How's that?
Yeah, the second one, the one with the positive times.
Anything else? Okay. The next thing is very similar, but we're going to be using different coordinates. Okay. These are called tangent and normal and cylindrical. Let me save this math file before I screw something up. This is September. Incidentally, if you notice here, it's saying that Saul was unable to do it with the inexact coefficients. What it does is it converts, whenever you have a decimal point in any one of those numbers, it will try to do it with inexact arithmetic. If you take out all the decimals, like for example, 0.75, write it as 3/4. You don't have to, but if you did, then what you'll do is you'll get an answer that is out, exact mathematics. They'll use fractions, and it's really pretty neat. But engineers always like decimal, right? So anyway, that's what math. Okay, so here we go. Going into the next section. This homework assignment is due, I think, next Monday. So you'll have a weekend to do what I'm talking about now. Okay. You have been using X. Normally, we think X is horizontal, Y vertical. It doesn't have to be, but 2 directions, straight direction. There are other ways to define velocities and acceleration. One of them is tangent normal. And in order to do tangent normal, what you have to know is you've got to know the path that you're on. Okay, so in this book, normally, so you know it's on. And the tangent normal direction is just like the I normally you think is horizontal, the J normally you think is vertical. In this particular case, you have a tangent direction and you have a normal direction. The way you find it is you've got to have a path. If you don't have the path, you cannot use this formula. Okay? So if you have the path, I'm right here on the path, you draw a tangent line to the path. And there are mathematical definitions for tangents, right? So if you have the mathematical formula for that path, you can take the derivative of the formula, and that's the tangent. If you don't, for example, if you can take the derivative of the graphic, maybe you've got the block, then what you do is you let your edge there, it's your tangent. Okay, but you've got to find the tangent. This direction is called the tangent direction, and I think the book uses a U. UT. That's the tangent
This
direction.
direction is called the tangent direction.
The second direction is perpendicular to this. Okay, 90 degrees off of this. So what you do is after you find the T, you draw a perpendicular line. And the normal direction along that line, the normal direction always points inward on the curve. Okay, so what's the inward side? Is it up here? Is this the inward? Is this the inward? How do you know? Yeah, you look at the curve, right? So this guy is like a bowl. So this guy right here is the inward side. See that? It's not too hard, right? Okay, so then you put the arrow and you say this is U, U, N.
Okay, so that would be the normal direction.
Okay, so that's the tangent.
Arrow here, and you say this is
Okay. The formula that you have is velocity. It's a vector. Is always equal to the speed. Your book uses the little lowercase v. It's the speed in the UT direction.
Is always equal to the speed.
So in other words, the velocity is always tangent to the path.
In the UT.
Always tangent to the path. Okay?
So in other words, your velocity is always tangent to the path.
The speed is equal to the time rate of change of the distance along the path. So for example, a circle, right? You know the distance around the circle. So if you know the diameter, radius of the circle, you find the distance around. Okay? The speed that that distance changes is your the dd. Okay? Lift B is speed. So that'd be like your speedometer. So this is the way you're doing things in the car, right? You're on the road, you're on I, you know where I is going, bends, weaves, whatever, and you got a speedometer that you're doing 110. All right, so that's your speed down that thing. Your velocity is always tangent, unless you run off the road. It's always tangent to the path. Okay. The acceleration has two parts. One part is the change in speed. So if you have your foot on the gas, foot on the brake, you're going to change your speed. Get the idea? And the direction of that is in the tangent direction. The second component is speed squared over radius of curvature in the in direction. This is this one here? That is a U. It's the unit vector in the tangent direction. Which is what? V is the speed. This is the change in speed. So this, you got your foot on the gas, speeding up. You got your foot on the brake, you're slowing down. V. Oh, this is the radius of curvature. They always write it as R. I think they just radius of curvature. What would be the radius of curvature on a circle with a diameter of 4? 2. Radius of curvature on a circle is the radius. Also, is it easy to find? No. In calculate, probably they had this really weird, crazy formula: dy dx squared. Remember anything like that? Man, that's how they calculate the radius of curvature of weird curves. Okay, if you can't find the radius of curvature, you won't use that formula. You got to have it. Okay, there are problems where I could give you the acceleration and ask what the radius of curvature is. I can do that, right? But you got to be able to get it. And most problems of the circle. Thank goodness, right? Any questions so far? This is what you got to do. Nope, that's it. What is it? Don't use unit vectors. So there's UT and a UN. Yeah, and normal, tangent, normal. And the way you find them is you have to know the path.
circle or something. Gotta have a pattern. The first thing you do is draw a tangent line. And that gets you your UT. Once you know where that is, then you can go 90 degrees and get the UN. Never get the UN and the T. Always the T, then the UN. Okay? All right, you want a problem?
Yes.
Okay.
How about it's problem 118? How about it's problem 118? One 118. Truck travels in a circular path. Let's see if I make it a little bigger. Man, I'm getting good at this. Scary thought. The truck travels in a circular path having a radius of 50 at a speed of 4. For a short distance from S equals 0, its speed is increased by B dot equals blah, 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 S, where S is meters. Determine its speed and the magnitude of its acceleration when it has moved S equals 10. Oh, man. Determine its speed and the magnitude. What are we going to do? What do you want to do? Okay, radius of 50. They tell me the radius of curvature. Thank goodness, right? So I got that. They say that it has a speed of 4 at some point. See? Like right up here at the top is speed of 4. And what does that B dot mean? Yes, a change in speed, change in V, right? So the V is changing by 0.05 S. And so what I want to know is what will be the V when I'm interested in it. I know it's 4 there, but when S equals 10, what's the speed going to be? How am I going to find that? I think I heard from somebody. I'm going to integrate, just like I did all these others, right? If I have dV dt, right? V dot, V dt equals the S. Okay? So how am I going to integrate this thing? So how am I going to integrate this thing? Well, let's give it a shot. You know what I'm trying to do, though, right? I need to find the V when S equals 10. Right? And we've done that before. That's how we got those equations, fancy equations. When acceleration is constant, we separate the variables, we integrate, right? That's what I'm going to do. You ready? Yes. Okay. You're going to have to help me because I'm not that good at it. Ready? It gives you the confidence, doesn't it? Say, man. Oh. Okay. V dot. Okay. dV dt. That's V dot equals. Okay, so V dot. Okay. 0.05 0.05 S. Okay. Now, what is the 0.05 S? Scary, but it's a different space. And how do we solve it? Okay. Now, what do you do? This is a differential equation. Don't mean to scare you. Can I? It's a differential equation. And how do we solve differential equations in this class? Separate the variables. I put the key over on the side. Separate the variables in this. I've got the dV separated. It's the only V. dV. What do you got on the side? I put dt over on the side. You can integrate. You got the dV. You could integrate SDS. You can integrate TDP, right? You can't integrate SDP. You don't know how SDP. Stuck, huh? Well, you remember that formula I gave you when writing one of the equations? It was D dV dt, no, D dV dx equals acceleration. You remember that? How did I get that? You don't remember? That's exactly right. Yeah. So here's what I want to do. I want to start off with this dV, but you see what the problem is up here? We can't see it. Problem right there? I can't separate the variables. So I have to do something else. So here's what I'm going to write. dV, and then I'm going to write SDS. Equals 0.05 S. Okay? Then I'm going to switch dt to ds. Mathematicians they say, oh, whatever. dV ds. And then I'm going to switch the dt and the ds on the bottom. dst. Mathematicians hate it because they say, oh, but equals 0.05 s. dst. What's dst? Equals 0.05 s. That's the velocity or the speed, right? So this would be dV ds times e equals 0.05. So this now separate. dV ds. Okay, separate the variables. Don't peek. You do it. Now separate variables. Okay, separate the variables and integrate it. Don't peek at me. You do it. See if that's what you got. Yeah. See if that's what you got. Okay. This guy right here, I just threw in the TS over TS. That's one. Okay. Then what I did is I took this piece and this one, and I just moved them aside, switched. And so that's a dV ds and a dst right here. And that is the derivative of the position to velocity. And so that's dV ds and a dst right here. And that is the derivative of the position to velocity. So first, okay. So can you find the speed, velocity, and s equals 10? What is it? So far, so good? Okay. So can you find the speed, velocity, when s equals 10? Can you find speed when s equals 10? How? Can you find? You can find the c. How am I going to find the c? Good. When position equals 0, speed. How am I going to find the c? Right? So when the speed is equal to 0, s is equal to 0, speed is equal to 4. So let's see, I'm going to put it in up here. 1/2. So when the speed is 4 squared is 16 equals 0 plus c. So c is equal to 8. Okay, now tell me the speed at s equals 10. Equals 0 plus c. So c is equal to 8. That'd be 100. Okay, now tell me the speed. Over 2 is 50. 50 times 0.05 be 5 times 2.5. Right? Yeah. Sure. Maybe. this screen. You get it? Okay. So 2.5 plus 8, 10.5. This screen. You get it? Is that right? So 2.5. I'm just plugging numbers. 10.5. It's what? Ooh, yeah. Boy, stupid. Okay. Yeah. I don't have a calculator. Just punch it in. Let's see, that'd be 2.5 times 2 is 5. Square root of 5. Is that what you're telling me? All right. I don't have a calculator. Punch it in. Okay, S is 10. So I'm going to put a 10 in here. So that's 100. That's 5 over 2.5. 2.5 plus 8 is 10.5. Square root of 10.5, 21. Square root of 21. Right? Okay. So speed is square root of 21. Let's plug in numbers in. Right? Okay. Yeah. So the speed is square root of 21. Here? Oh, the speed was 4. 1/2 times speed is 4. S is 0. It's given in the problem. Right. The problem says right up here. S equals 0. The speed is 4. It's given in the problem. Right. The problem says right up here. Not yet. Right. So now I have the speed, and what it wants to know is what's the magnitude of the acceleration. Magnitude of acceleration. So I'm going to find the acceleration, then I'm going to find the magnitude. Okay. You ready? So what's the acceleration? Give me a formula for acceleration. Yep. And I'm not in IJ. I'm in tangent normal. What was the formula for acceleration? Acceleration was equal to v dot in the tangent direction plus what? Speed squared? Come on. Doesn't want to take my square. Divided by radius of curvature in the normal. Okay, so let's plug in acceleration. What's v dot? 0.05. So plug in. What's S? Acceleration. What's v? Right now it's 10, right? So that would be 0.5. Right? 0.5S. 0.5 in the UT. 10, right? So that would be 0.5. Plus. What's the speed? Just calculate. Square root of 21. Square in the UT. 21. Plus. What's the speed? Just calculate. Radius curvature, they said was 50. Square that. 21. Radius. There we go. How do you find that? 50. Right, it's Pythagorean theorem, right? So you take the square of this leg, square. So what this is the magnitude of acceleration is equal to square root 0.5 squared plus 21 over 50 is equal to square root 0.5 squared. Okay, so let's back up. What did you do to this problem? What do we have to do? They said an acceleration. So I've got to find the acceleration equation. Right? How did I know to use tangent and normal instead of I, J.
They said they
Yeah,
want
you have a question?
acceleration, so I've got to define an acceleration equation.
It is 21 because let me look back here.
Instead of I. Okay,
Yeah, it was just it's the square of the velocity. Yeah.
Is
How do I know it was tangent normal and not IJ? Because you're going to have to take an exam from me, right? And I'm not going to say, okay, use tangent normal here. Why would you look at this problem and say this is definitely, and don't say it comes out section 4. That would help me. Okay. How would you say that this is a tangent normal? Okay, circular path. If you did not know the path, you can get doing tangent normal. That's a dead fire sure thing. And it's forget it. Okay, it's like circular path. You did not know what path is on? Nope. Then would you use tangent normal? Nope. Right? Because you got to know the path. So that's a dead giveaway. Now I can do weird things to you, right? And I can say. Just that. What else? What else? Special. What were the other given? That changes. Okay, the speed of changing. Right? Those things are that formula. Speed changes. What else? The velocity. I gave you the speed. Speed. Giving you the path. I'm giving you the change in the speed, and I'm asking you for velocity. You see those things? Those are the keys that when you read the problem, you say, aha, this is going to be one of those tangent normal things. You got it? Okay, so on an exam, you can spot it. Okay, so on the next question, I might come in here and have you ask you a question and say, is this or is this not a tangent normal? And you'll pass it, right? Good. Okay. Let me do the next one. How much time do we have? Oh, 5 minutes. Okay. Well, let's see. Let's do another tangent normal then. The next one. How much time do we have? Oh, 5 minutes. Okay. How about 131? Yeah. How about 131? I think so. I thought it was it? What was the V dot? It was yeah, because it was V dot was 0.05 times S, and S was n. Okay, I'm going to go to 131. Okay, I'm going to go to 131. Okay, let's see. At a given instant, the engine at E has a speed of 20 and an acceleration of 14, acting in the direction shown. Determine the rate of increase in the train's speed and the radius of curvature of the path. Why is this going to be tangent? Okay, rate of increase. I haven't seen that in any of the other formulas. I want the acceleration. I want radius of curvature. Can you spot those things? And go, aha. Even though it is that second. But on the test, you those things say, ah. He's not going to. Right? Okay, so say it's a. Am I going to do it? Tangent. No. How am I going to get the radius of curvature? Right? So, how am I going to do it? Tangent north. How am I going to do it? How am I going to? Huh? Okay. Do you have a formula for the radius of curvature? Okay. So there was an acceleration term, and there was the the change in speed, u tangent, plus speed squared over radius of curvature, u normal. So you find the normal acceleration? How big is the normal acceleration? How would you find that? Huh? Is it given? Is it this 14 guy right? Is that the normal? Where does the normal point? Inward. That's pointing inward. Perpendicular to what? From the tangent, right? I told you first you find the tangent. You don't ever go in there and look for the in, right? You don't look for the normal first. You look for the tangent. Where's the tangent? From the tangent. You do. Yes, you're ahead of me. Yes. Okay, this is tangent direction right here. You see that d equals 20? The velocity is always tangent to the path. Okay, so draw a line perpendicular to that. It's drawn on the book. Can you see it? It's this guy right here. This thing right there. See that line? That's perpendicular to the speed. See that? Okay, so I want the amount of acceleration along that line. How do I get it? I want the amount of this that's along that line. That's the normal amount. You see that? So how do I sort this? 14 times what? Cosine of is, well, where's that angle measured from? No, 75 is from here. So how do I it's the sine of 75. Got it? Where's that angle? Or cosine? No, 75. Yeah. Okay. Right. Right. So it would be 14 sine of 75 is the normal acceleration, and that equals speed. What was the speed? 20. 20 squared divided by radius of curvature. Can you solve this? Okay. Then what else do you want me to do? Determine the rate of increase in train speed. You want v dot. How do you find v dot? Then what else do you want me to do? Determine the rate of increase. You see this term right here? What is the tangent component of acceleration? The tangent component of acceleration. You see this term right here? 14. What is the tangent? Right, you want this acceleration. Cosine tangent. See that? 14 cosine times 14 cosine 75 equals v dot. See that? Is it speeding up or slowing down? 14 cosine 75 speeding up. This velocity is going this way. This is acceleration. Is it speeding up or same way? It's going faster, 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 faster. That's my 2 minutes. What else do you want to talk about? Last minute question. What is the normal? What else do you want to talk about? And we already. Last minute question. The normal is right here. Yes, 14 sine 75 is the normal acceleration. 14 is the acceleration. This one here? Yeah. Below. No. US. Yeah. Okay, this is the tangent acceleration. Okay, that's the normal acceleration. Okay. Because he's that much in that direction.